Hello everyone. Today I am going to discuss about design patterns. I'm using a Java program to conduct it. And there is usually used to commonly when we want to solve commonly occurring problems, and those design patterns act as a blueprint, and there we can customize those blueprints to solve more often design problems in our code. And it's not just a piece of code, and it's a general concepts for solving a particular problem. And when you consider about types, there are three types. And when we want to provide object creation mechanism, we use creation of patterns basically. And uh, structural patterns explain how to assemble objects and classes into large structure. There are several design patterns for each of these types. And last one is behavioral patterns, and it takes it takes care of effective communications and the assignment of responsibilities between objects. And today, uh, for creational methods pattern, I'm using one of the design patterns, that is factory method, to conduct behavioral design patterns. I choose adapter pattern, and lastly, I choose uh, observer patterns to uh, demonstrate behavioral patterns. So let's take a look at this code, and this is a interface, that is notification interface. And this interface defines method notify user, and this method will be implemented differently here. So that's, you can here I've created two uh, concrete products, and it is email notifications and SMS notification that implements by using this notification interface. And there we override, which is we have created method public notify user. This method is overridden by uh, overridden by there, and there is not much content in this method, and just print sending an email notifications. And then it's the same concept there is it's SMS notification, special notification concept that is used in it's created using this interface. And then it's override means it's same as there, uh, just different with is type. And then there's a abstract the notification factory. At this actual implementation is there. You can see create notifications, and then created what is called, and notify notification factory. And is abstract class that declares a factory method. Then factory method is this one. And we also created this notifications, and there we created this notification type, create notification, and it's a one variable. And then I have used the method notify user. That's called differently when I will explain it later, which is I can explain this notification uh, is different when we call for these two different objects. This is using that factory we created different objects when we want. So that's basically what we do here. And when we consider about this email notification factory and SMS notification factory, use are it's subclasses, and these are subclasses from notification factory. The notification factory, these extends mean. that subclasses. These are the subclasses. Email notification factory and SMS notification factories that are involved. Create notification methods are there. There you can see create notification method. This is notification methods. That's overridden by there. When we want to when it call to this, it will generate. Sorry, it will create checks called email notification and notification types, and then if you go this one, that is a similar thing is happen there. So SMS notification the objects is created, and this is like client code, and so like a client code is that use those different objects. So I created two variables that is easy to use there, and factory one and factory two, and this notification methods, and I created this notification objects, and it is saved in assigned to factory one variable, and there it's a SMS notification that is same. I mean, same thing happens there. If I want to create a, like say X notification factory, then this what we have to do is only because there is a, create another concrete products and then create a method for that in there. Those is not in client code. So and then there's no need to create everything. It's abstract and there what we want to is call it. And in actual scenario, the user is no need to work with the code. User just click on the button and like that they were doing some events and then call into APIs and it work according to the create. They work. They created the necessary objects. What in that particular time, what type of the object is created, what need to create, and then it create and then it use it here. So that's it's kind of a dry method, and that's all about. If I run this code, what will happen? It create a this mail factory method, and when we call to that notification method, it will print that output. We have written there only out no, so sending no. Yeah, yes. Sending email notification is in the email notification what we have written. Sending an email notification will be printed. And if I created there factory two new no objects is assign factory two, and it didn't call to send notification method that is send in SMN at southeast. Yeah, send in as SMN notification. That's only the body. That's what we print here. When it run, you can see that output. So just getting some time, and yeah, these two are the outputs. Okay, I think you have get an idea. What is the purpose of having this factory method is to create a new object, because at the beginning uh, we can't uh, exactly guess whether this is the only types of objects or this is whether there can be uh, uh, wants to add a new types of objects, then that without using these factory methods, if we done, there we have to do a lot of coding and still it will very unnecessarily we have to code, we have to change the code from many places. So that's all about factory method. And when you consider about the adapter method, and method is a type of a structural design patterns. So yeah, in here, what is the purpose? Is in here if we want to add two different phrases design incompatible with each other's, and they don't work together. To solve this problem, we use adapter. So using adapter is actually objects. and yeah, so shape interface is defines a high method. No, this is about interface, that is client method, and there are also interface. Okay, yes, yeah, I created the implement shape using shapes. And I created the override. It's a same concept like previously code, and it's overridden, it's there. So these two are concrete products I have created, and then circle classes are rectangular adapter class. So rectangular adapter implementation here, you have to create a private rectangular this rectangle code. Now origin is there. Uh, origin is there. Sorry, rectangular adapter class implements the shape, which is interface act and act as an adapter. Uh, which is the rectangle class, and it contains a reference to a rectangle objects and adapt. It's in this method. And shape interface do method, and they are also client code. When I go to the client for code, yeah, this is our client code. This is the main method. So use the shapes interface client code, and it is actually the client code implementation. This is the main method, and the usage of shape interface to draw different shapes. I have created two different, and it create an instance of a circles and calls it to draw a method as called the method, and it creates an instance of rectangle, but needs for the adapt to the steps. That's it. So this is when you need to work with incompatible mm, interfaces. We use adapter. It is objects. Using that adapter, we can work with each other. So let's run the code and see the output. So yeah, draw in a circle and draw in a rectangle. So do two different uh, outputs there. So yeah, that's it. And let's take a look at the observer patterns. Observer pattern is type of a behavioral patterns. I chose here one of them. So how it works together. So that's uh, this is responsible for assignment of responsibilities between objects that what I mentioned before. This coding demonstrate, and it's temperature sensor object is created this there. Sensor created there. So I'm created two private observer. There's a observer one and observer two. So as two observer is one of the so when we consider about which is holds a reference to observer, two different observers, and observer one and observer two, and and here I check the observer one is null. So if it is not null, then update, and so two is null, then it update. It's if else condition is true, that, uh, and yeah, they are created two different, and you consider about subclasses like uh, temperature sensors subclasses. So maintains list of, yeah, they are maintain list of uh, observers in this case. Up to two, there's only two. If you don't need to add another one, you can add here. So, and provides methods to register observer, set observer and set observer two, and then notify observers to changes via the update temperature method. There's update temperature method. It just the pass parameter is called type temperature, and then in here we created complete observer two classes for that each of this. It is the creator two observer classes and digitally display and analog display. uh, and each provides its own implementation of this update. This is related to digital implementation, digital display implementation, and this analog display. And in the client code, it's temperature sensor and registering observers and updates the temperature triggering of notification to the observer. So yeah, it's a two different objects that I created using this set observer method and set observer two methods. And there we use this sensor pad to this particular two uh, methods. It's when you can pass it 25 and price there and so that's all about. And when you can about this observer and run this code and see the output. Yeah, digital display temperature update to 30 degrees. Hello, okay. This 30 degrees and you update it. If I updated this once again, that will also appear in another time. So that is observer pattern. This used to just it is it comment it very useful when we want to communications between objects. That's the idea behind this concept. So that's all about my presentation, and thank you.